Right, we're going to do a second featured video today. Just had these irons arrive, and they arrived like that with the plate hanging out and the end of the iron broken. Now sometimes you just don't know whether that's happened in the post or whether the customer sent them in for that particular reason. Unfortunately for me, there's no paperwork with this pair, but I do have a name on the label from an old delivery on this packaging. So I've looked, and I have actually spoken to this customer via email, and she's paying an extra £15 to have the arm changed. So our repair service fee covers everything, but it does not cover replacement of broken arms or ceramic plates that are scratched or damaged for some reason. So I thought we'd just go through changing the arm. I've just gone to my spares drawer, and we have a arm. Not quite. I mean, this pair is a particularly good condition, which is highly unusual for a 4.0. It's quite an old model, but I've found the best arm that I've got, which actually isn't too bad at all. It's not as good as the customers, but the customers is broken, so unusable, and this is a very old model now, so I'm sure the customer will be more than happy. Got a few signs of wear, but no real marks. Well, a couple of minor marks on the ceramic plates. Overall condition is pretty good. Hinge caps are present, but they are a little bit worn. The cable feels a little worn and twisted, so I'll be changing that. It's probably working fine, but excessive twisting and just my gut feeling that it's all a bit floppy means I would fail that in the visual inspection of a pat test. Hinge cap is broken. That's a common problem when you take these off. Very fragile, very old, this model, so that one is okay, but it's very easy to super glue these back on once we've finished the repair. So we're going to undo the pivot pin screw. That is absolutely solid, so we'll move over to this one. In case you're wondering, I have a Phillips bit embedded in the work surface. I've just drilled a hole, and with some epoxy I've just put that bit in, but this one slips at a certain torque, which is quite useful because it's like setting a clutch on the screwdriver. This doesn't have that feature, but with this, doing a mark, it does slip a low torque, which is perfect. The other one, which is just off camera, is embedded in the work surface as well, but that one does not move. That is absolutely solid. So I've got the choice of two, and if I do get a hinge pin screw that won't undo with the screwdriver or brute force with one of these, I just use the weight of an impact driver. The weight behind this normally will break the grip on the bit that's over here, and if it doesn't, then I will put it on that bit over there and give it a whack with a hammer, but that's pretty unusual to have to do that. Anyway, let's get these apart. Note the orientation of the hinge spring. Two forks go down and forward towards the switch. So we're going to remove this cover, and then we're going to remove the cable cover and get that cable changed. Get that done and out the way. Actually, we were going to transfer everything to the new arm, so and what we will do is we will use the customer's cable cover, or we will use the customer's arm cover, because they will probably be in better condition than the ones I've got. There's two screws securing the circuit board in place, and we'll just remove those and lift the whole thing out. That will leave behind a heat pad, and it should be two silicon pieces, but one of them has obviously fallen out. So I will go to my container with thousands of silicon pieces, and we will grab another one. This arm, nothing we can do with that unfortunately, apart from save the little split collet. It's a cable retainer or restrainer, whatever you want to call it. There we go. And unfortunately that has to go off into the bin. It's a shame. It's good condition apart from the damage. We'll unplug the cable. We will unscrew the UK adapter. Our recycling place or scrapyard where I take all these cables likes the cable to be separated from the ends, so rest assured all of that gets recycled. We're going to grab our new arm. We'll take the cover off. I'll put that to one side, that will go in my spares drawer. We'll take the cover off. Same, that will go into the spares drawer. Right, pad in, silicone rubber pieces go into little moulded pieces there that they sit in. We are then going to, actually we'll take that off because this arm's already got that fitted, and we'll just slide that in place, and that goes in like so. So we're going to put the screws back in, circuit boards all lined up nicely. And we'll pop a screw in. And then the second one, just going to make sure that those wires are not in the way and they're pushed down properly, which is good. Now we're going to just inspect this socket. It all looks good, and we're going to grab a new type 1 cable. We're going to use the customer's adapter. We're just checking the fuse that's fitted. It's a 5 amp fuse. That's fine. You want to fire a 3 or 5 amp fuse. Either is okay. I would stick to 3 if you've got it. A little bit of contact grease onto the cable. Split collet cable restrainer is in place. That's correct. And we'll just feed that in there. That all looks good. Oops, cable cover back over. Oh, this is slightly different to the other one. Shouldn't be. They're exactly the same model. That's interesting. Yeah, very slight. That is very slightly different, and I wonder why. Interesting. Definitely a 4.0 arm. I had never noticed the differences in the end covers before. So, oh no, we've got a cable retainer missing from that one. Let's go back. We'll use this cable retainer, or maybe this one actually, whichever one's got the holes not filled in. What happens is there's 2 locating lugs. You can just see them in the bottom there, and they very often break. This one's got both broken off, as you can see just in here. Those plastic pieces get stuck in the holes there. You can drill them out, but I've got one here that has no problem, although it's going back into the ones with the broken pieces, so I'm actually going to put that one back in because it doesn't matter in this case. And there we go, that's on this time correctly. Obviously crucial those restrainers go back in, these split collets as I call them, probably incorrectly. They are cable retainers, and we've got nice secure cable, spins freely. Now, are there any other problems apart from that broken cable? Well, that's a good question, and now we'll go on to check everything else. Cable feels good. Going to check the thermal fuse first, low ohms range. Yeah, that's good. And okay, the elements are also good. So we've got all the silicone pieces in place. There's one here, one in the irons, and we'll put the cover back on. This is the customer's cover, which is in slightly better condition than mine. we will move on to the other side. Again, really nice condition for such an old model. Okay, so the resistor here, R8, can fail, especially if it is one of the, you see that black flat sort there? That's the old version. They failed all the time. If we had one of those fitted in that position, we would be changing it, but we've got the newer type resistor there that is relatively reliable, so we will not need to change that. What we do need to do is just take care of a little issue here with the thermistor. You see that black thermistor is actually stuck in place with a little adhesive pad that's very, very thin. It's double-sided adhesive, but eventually that will harden enough and that thermistor will fall off. When it does that, the ions will overheat and blow the thermal fuse. So what we do, we grab some T-Core 75. This is a very expensive adhesive, silicone adhesive, and we will just apply some to that thermistor, and that will set overnight as these go back to the customer, and that means that that thermistor can never fall off of the element, so we won't have these coming back with that particular fault. So we do take care of all of these little known issues, whilst other companies might like to have them back in a few months' time or whenever that thermistor has fallen off. Or I tend to do a proper job in the first place and take care of these issues. I don't think it's fair that the customer's forked out for a repair and you haven't taken care of these minor problems that will affect the reliability. You know, if it was a major problem and you had to spend a lot of money changing parts to make it reliable, well, that would be a different thing. That would then increase the price of the repair, and then the customer would have that choice given to them. But in this case, that's cost me, what, 30 seconds and a few pence worth of T-Core 75. So, right, we are now done. Cable spinning very nicely. I think the customer will be happy with that. So yeah, on and heating up both sides. We're going to pop that one cap on that is okay, and now we're going to have to apply a little bit of super glue very carefully to the edge of the hinge cap. See if I can get that in place. We're just going to wait until this is heated up. Yeah, that's fine. These are overshooting the temperature because of that thermal paste, the silicone that's on there, just cooling things down a little bit, but that will have set by tomorrow when the customer gets these back. And right, we're just going to hold that cap in place. Whilst we're doing that, we're going to do a class 2 pat test at 500 volts, and there we go, making sure the switch is in the on position. And that's test 84 and a pass, so we are good to go. So yeah, done. So that is the GHD 4.0, it's an arm change, and yeah, there we go.